The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to review for the Chapter 5 test. Monday is test day. There will be no regular class. Basically, you can take your Chapter 5 test anytime from now until Monday night at 11:59 p.m. Just a reminder, once you open the test, the time starts. And if you want to send me work for problems that you got wrong to see if you get extra credit, you can do that. Also, then next week, Tuesday, Wednesday, Thursday, and Friday, we'll be reviewing for the final. The plan is on Tuesday to do Chapter 2, Wednesday, Chapter 3, Thursday, Chapter 4, and Friday, Chapter 5. And we'll pretty much stick to that schedule, but if somebody shows up and they don't have questions from a given chapter, we can still look at other chapters as well. All righty. Anyway, so let's get started. Karina, do you have any questions you'd like to look at?
I actually did not get a chance to look at the review yet. I would like to do a little bit more of the problems we did yesterday, though, so that I have a better understanding of my operations.
So the long division?
Yes.
Long division where there's a missing term kind of thing?
Yes.
Okay. Let's see. Let's do this. Give me just a minute here. And I'm going to open WebAssign and look at some problems in there. Give me just another minute here. Okay, let's see. Wait a minute, that's not what I wanted. Sorry. I was opening the Math 95 class. That would not have been helpful.
That's okay.
Yeah, okay. Let's see here. Okay, so here's one. It says, perform the division. And we have a squared minus 49 divided by a plus 7. Okay, so the divisor goes outside, the dividend goes inside. They are both already in descending powers. That's a good thing. However, we see that in the dividend, there is a missing power. So what we need to do is put that missing power in. So we've got a squared plus 0a to the first power minus a to the 0 power times 49 if you want. Anyway, are you okay with that so far?
Yes.
All right, so now we take the leading term inside divided by the leading term outside. A squared divided by a equals a. We put that in the proper column where the answer goes. Then we take that number, a times the divisor, a plus 7. Distributing, we get a squared plus 7a. We take the results and put it over here. We then subtract that from what's up above, but we're subtracting the entire binomial. So then we change it from subtraction to addition of the opposite. Okay, so far?
Yes.
Then we add up the columns. A squared plus negative a squared is 0. 0a plus negative 7a would be negative 7a. Then we bring down the next term and start the process all over again. We're going to divide the leading term inside by the leading term outside. Negative 7a divided by a is negative 7, or in this case, minus 7 there. Then we take that times the divisor. We get negative 7a minus 49, which we put over here. Then we subtract the results, changing it to addition of the opposite, adding up the columns. Negative 7a plus positive 7a is 0. Negative 49 plus positive 49 is 0. So our answer is a minus 7. Let's check our work. If a minus 7 is correct, then a plus 7 times a minus 7 should equal a squared minus 49. Let's see if it does. This is a squared minus 7a plus 7a minus 49. Combining like terms, the middle two terms disappear, and so it checks. Good to go with that one?
Yes.
All right. Let's see here. How about this one? X cubed minus 1 divided by x minus 1. So we're going to have x minus 1 on the outside. On the inside, x cubed plus 0x squared plus 0x minus 1. So again, each missing power after the highest power, each one below that that's missing, we need to create a column to put those numbers. Any questions there? All right. We'll take the leading term inside divided by the leading term outside. X cubed divided by x is x squared. Then we take the x squared times the divisor, the x minus 1. Distributing, we get x cubed minus x squared, which we put over here, x cubed minus x squared. But we're going to subtract that quantity from what's up above. We'll change subtraction into addition of the opposite. Adding up the columns, x cubed plus negative x cubed is 0x cubed. 0x squared plus 1x squared is 1x squared. We'll bring down the next term, 0x, and start the process over again. Divide the leading term inside by the leading term outside. X squared divided by x is x. So we have plus x. Then we take the x times the divisor. Distributing, we get x squared minus x. So this is x squared minus x. Am I going too fast?
No.
All right. We're going to subtract this quantity from what's up above. Change it to addition of the opposite. X squared plus negative x squared is 0x squared. 0x plus x is x. Bring down the next term, the minus 1. And once again, start the process all over. Divide the leading term inside by the leading term outside. X divided by x is 1. So we get plus 1. Then we take the 1 times the divisor. Distributing, we get x minus 1. We're going to subtract that quantity from what's up above, changing subtraction into addition of the opposite. X plus negative x is 0, negative 1 plus positive 1 is 0. So here's our answer, and there is no remainder. Okay, let's take a look at another one. You ready to go on?
Yes.
Okay, this is a cubed plus a divided by a plus 4. So a plus 4 goes outside. A cubed plus 0a squared plus a, and then plus 0 as the constant term. We may or may not need that 0 at the far end, but we'll know when we get there. Okay. So divide the leading term inside by the leading term outside. A cubed divided by A is A squared. A squared times the divisor A plus 4 gives us A cubed plus 4A squared. So A cubed plus 4A squared. We're going to subtract that quantity from what's up above. We'll change it to addition of the opposite. A cubed plus negative A cubed is 0A cubed. 0A squared plus negative 4A squared is negative 4A squared. Bring down the next term, the plus A, and start the process all over again. We'll divide the leading term inside by the leading term outside. Negative 4A squared divided by A is negative 4A. So minus 4A. We take negative 4A times A plus 4 and we get negative 4A squared minus 16A. So negative 4A squared minus 16A. We'll change that. Let's see, we'll subtract that from what's up above. Change it to addition of the opposite. Add up the columns. Negative 4A squared plus 4A squared is 0. A plus 16A is 17A. And then bring down the plus 0. Start all over. Leading term inside divided by leading term outside. 17A divided by A is plus 17. So then we take 17 times A plus 4, which is 17A plus 68. Oops, not 16. 68. Subtract that quantity from what's up above, change it to addition of the opposite. 17A plus negative 17A is 0. 0 plus negative 68 is negative 68. So we've got A squared minus 4A plus 17 plus negative 68 over A plus 4.
I have a question. Because it's a negative 68, can we make it a minus 68 over A4 or no?
Like that? Yes.
Yes.
Either way,
Okay.
the textbook tends to do it the way I wrote it first. Let's see. Give me just a second here.
Okay.
I'm going to write. Well, here, let me do this. So here's where I'm getting this problem from. Let's put in my answer and see what happens. So let's see, I've got to have A squared. So let's see, A squared, and then minus 4A and plus 17. And then let's see, minus fraction up on top, we've got 68. And in the divisor, A plus 4. Is that a plus sign? I guess so. Let's see what it says. Ah, your answer cannot be understood or graded.
Okay.
Now, okay. Let's see. So I put a plus sign there and a minus sign in there. Let's see if that makes it correct. Interesting. Okay.
Usually when I'm entering my answers in there, I don't do the parentheses.
Well, I didn't intend to, but let's see what's going on there. I used this, but that automatically gave me parentheses. Oops, don't want to do that.
I usually add the first number and I use this like the slanted sign on my keyboard to make it a fraction.
Yeah, okay, we'll do that. Let's see. So -68 divided by
Oh, I still did it.
yeah. And I've got my negative outside there. Of course, this is now what is it? The definition of insanity, doing the same thing over and over, expecting the same results. Maybe we need to do this. Maybe I need to go back and let's check my work and see if I made a mistake. Maybe I'm just the answer's completely incorrect.
Yeah.
So let's see. A cubed plus, I'll go back to my other screen. I'm glad you asked about that. Where's my mouse? There it is. Okay. All right. So the problem is correct written. A cubed plus A over A plus 4. So A cubed plus 0A squared plus 1A plus 0 divided by A plus 4. A squared A cubed plus 4A minus negative plus minus 4A squared minus 16A plus 17A plus 0. Let's see, 17A plus 68 minus. Let's see what it says for more information.
Okay.
That's not helping. That's not what I wanted. Your answer is not counted as omission. There's no starting. Common errors listed below. Well, here's what I'm going to do. Hang on.
Okay.
I'm going to pause. All right, so we've checked our work, my work, whatever, concluded that this answer is correct. Not really sure why WebAssign isn't accepting it, but just let me say this about that, okay? On your tests, I look at every one of your problems that you missed to see if it's a situation like this. So for instance, this problem, they marked it wrong, but I would look at it and go, I don't know why WebAssign isn't accepting it. And I would change it to being correct. So don't panic about that. But yeah, I am frustrated as what's happening there. But you said that, so 13?
Yes.
And yours, of course, is slightly different from this. Do you want to look at yours or this one doesn't matter?
Let me see here. I want to see if it's the same one. It is the exact same one.
Oh, okay.
Okay.
All right. So let's see if we can get this one to work. All right. So my divisor is going to be 5x minus 1. And my dividend is going to be 15x cubed plus 2x squared plus 24x plus 3. So I'm going to take 15x cubed divided by 5x, which is 3x squared. Okay. That's going to give me 15x cubed minus 3x squared. I'm going to subtract that from up above, but I'm going to change it to addition of the opposite. So I get a 0 here and a 5x squared, excuse me, there, plus 24x. 5x squared divided by 5x is what? X. Okay.
Yes.
X times 5x is 5x squared. X times minus 1 is minus 1x. Subtract that from above, change it to addition of the opposite, 0 and 25x plus 3. 25x divided by 5x is plus 5. We get 25x minus 5. subtract that from above, change it to addition of the opposite, and we get +8. So we've got all of that +8 over 5x minus 1. All right, so let's see what happens. Is that the answer you got?
Let me flip back through my pages real quick. Make sure. Yes.
Okay. So 3. No, that's not what I want. 3x squared plus x plus 5 plus, and then I'm going to try this again, though it didn't work before, so I don't know why it would now, but maybe 8 over 5x minus 1. Ah,
Yeah, and it didn't give the parentheses this time. That's weird.
yeah. Yeah, I see what you're saying. I don't know. Back up at this other one. No. I'm going to try this one last time, which is probably crazy. No, it's not what I want. Well, I guess I got to get rid of that. So if we go plus, and then let's see what was it. Plus, and then it was negative 68.
Yes.
Get there. Oh, hang on. I think I may have discovered what I was doing wrong. We'll see. Okay, then now I'm going to use this. See what happens.
See?
Nope, still didn't like it. I don't know.
Technology. Gotta love it.
Oh, well, yeah, for sure. Anyway, okay. Other than that, I can't seem to get it to accept the right answer. You got anything else you want to look at?
Maybe if we can go over the rules of the powers when you're
So like
multiplying.
section 5.2, multiplying two powers with the same base, subtract or dividing power raised to a power, all that stuff.
Yes.
Okay, so let's see here. Let me turn to page is this on 5.2. In the actual textbook, this is on page 356.
Okay.
Nope, that's not the one I want. That's for 5.1. I want it for 5.2. Page 364.
Okay.
Okay, so the product rule. Multiplying two powers with the same base, you add the exponents. So let's say I've got a cubed times a squared. That's a to the 5th power. Or if I've got b to the 4th power times b times just, well, let's say b to the 5th power, that's b to the 9th power. What if I've got b times b to the 6th power? Don't forget there's an implied one there. So this becomes b to the 7th power. Okay.
Okay.
So there's that first rule. Be careful though. Let's say I've got x cubed times y squared. That is not xy to the 5th or x to the 5th y or whatever. It's just x cubed y squared because the bases aren't the same. So this rule doesn't apply to that situation. Okay.
Okay.
Next rule called the power rule. If you've got a power, raised to a power, there you multiply the exponents, not add them. So if I've got y cubed to the 4th power, that's y to the 12th power. Z to the 8th to the 5th power is z to the 40th power.
Okay.
Now, contrast that with this. Let's say I've got y to the 3rd times y to the 4th. That's y to the 7th. So these are different, but yet they've got the same exponents. So you got to be careful of getting these two straight. Okay. And then z to the 8th times z to the 5th would be z to the 13th.
Yes, because you're adding them. Okay.
Correct.
Got it.
Correct. Okay. This says power of a product, xy to the n power, x to the n, y to the n. So if you have a product with an exponent outside, you take the outside exponent and attach it to each factor inside. So 4xy cubed is 4 cubed x cubed y cubed.
Okay.
Then you'd go back and say, well, 4 times 4 is 16 times 4 is 64. So we get 64x cubed y cubed.
Okay.
Okay. Let's see here. Let's combine rules 1, 2, and 3. Let's say I've got this. A squared times a cubed to the 4th power. Okay. So that first rule, which was multiplying 2 powers with the same base, we add the exponents. Inside, I'd have a to the 5th.
Okay.
Okay. Now I've got a power raised to a power, so I've got a to the 20th.
Okay.
That makes sense.
So inside first, then outside. All right.
Yeah, order of operations. Let's say, what if I've got this? X cubed times x times y to the 4th, all of that to the 5th power. So first of all, inside I'd have x to the 4th, y to the 4th, right?
Yes.
Then I'd have x to the 4th to the 5th, y to the 4th to the 5th. And then I'd get x to the 20th, y to the 20th. So there I used all 3 of those first rules.
Okay, perfect.
All right. Quotient rule. X to the m divided by x to the n, x to the m minus n. Now you've got to be careful, because with this rule, multiplying 2 powers with the same base, adding the exponents, you can add n plus n or n plus m, it doesn't matter. But here it's got to be the top exponent minus the bottom exponent.
Okay.
So if I've got, let's see, x to the 17th power over x cubed, that's x to the 17 minus 3, or x to the 14th power. The other thing you've got to keep in mind is the result is in the numerator.
Okay.
So like there's the implied 1 down there.
Yes.
Okay. Power of a quotient rule. So if I've got a quotient raised to a power, I attach the power to both the numerator and the denominator. So let's say I've got 3 over x to the 4th power. That's 3 to the 4th over x to the 4th, or 81 over x to the 4th.
Okay.
Let's say I've got x cubed over y squared to the 5th power. So applying this quotient rule, you'd have x cubed to the 5th over y squared to the 5th. But now, power raised to a power, x cubed to the 5th is x to the 15th, and y squared to the 5th is y to the 10th.
Yes.
So again, you see how we're using more than one rule there.
Yes.
Now, we can take this rule and oops, not a 2, in. So we can take the power of a product and the power of a quotient rule and combine them. Let's say we've got this. So I'm going to apply the 4 to everything.
Okay.
X to the 4th, y to the 4th, over z to the 4th, whoops. W to the 4th. So it's sort of a combination of those two. You okay with that?
Yes.
All right. X to the 0 power equals 1. X to the 1 power equals x. Again, be careful not to get those two ideas confused or mixed up.
Okay.
Do you need examples of that or?
No, I remember that one.
Okay. And then negative exponents. Let's see here. X to the negative n is 1 over x to the n. But likewise, you could say 1 over x to the negative n is x to the positive n on top. So basically moving it down, moving it up across the fraction bar there changes the sign of it. Okay.
Okay.
Now, you could say this. That's also true, though usually we don't want that. We want an answer where it's got a positive exponent. Okay. The exception would be scientific notation. If you've got like 3.41 times 10 to the negative 3 power, that's in scientific notation. You would just, you know, unless it asked for something different, you'd leave it like that. You wouldn't rewrite it like this. Okay.
Okay.
That's equivalent, but that's not scientific notation.
Yes. Okay.
Let's see here. Oh, also, if you got something like this, so you can bring the top down and bring the bottom up. Moving this down makes the exponent change sign. Moving that up makes the exponent change sign.
Yes.
And then this. Does that make sense?
Yes.
Okay. Do you want me to do anything more with that?
Nope.
All righty. Anything else you'd like to look at?
I think that's it.
Okay. Well, I'm going to go tear my hair out and try and figure out why WebAssign won't accept that one answer. I'm going to keep playing with it to see if I can figure it out. But anyway, you have a great day. Good luck on your test Monday. I'll be back at 1:15. Should you change your mind or have any other questions?
Okay, thank you.
You betcha. We'll stop the recording.